Okay, so this is L3 for Unit 8, and we're adding and subtracting rational expressions, okay? So the objectives, of course, is going to be adding and subtracting rational expressions using LCD. Okay, so using LCD, we're just going to review adding and subtracting fractions because the same concept applies, right? So here I'm adding these two fractions. I need the LCD for these. So I have 1/2 plus 2/3. You see the denominators are different. So I need to make them the same, the common denominator, right? So I want to multiply the first one by 3 over 3 and the second one by 2 over 2. So that the bottom has 3 times 2 and 2 times 3. You see how they're the same? Now I have 2 sixths plus 4 sixths, which gives me 7 sixths. Okay. Let's do one more. I have 5 sixths plus 2 fifteenths. You see here, a lot of people might think, oh, I'm going to just multiply 15 over 15 for the first one and then 6 over 6 for the second one. Well, that's going to give you a common denominator, but it's not going to be the least common denominator. Okay, so to get the least, which is the smallest common multiple of these numbers, you need to break them down to factors. So I keep the top of the top, doesn't really matter, right? I break the bottom down. 6 is 2 times 3, and 15 is 5 times 3. And I'm going to see, well, what factor does one has that the other doesn't. Okay, so the first one I have 2 times 3, and I need a 5 because the other one has a 5, right? So I multiply the first one by 5 over 5. Now the second one, 5 is already there, 3 is already there. I'm missing a 2, so I'm going to multiply the second one by 2 over 2. Okay, so I end up having 25 over 30 plus 4 over 30, which gives me 29 over 30. All right, so let's use the same idea and apply that to rational expressions. Okay, I'm going to start with example number 1. I have 1 over 4x squared plus 3 over 16x. Again, I need the least common denominator. So I'm going to break the bottom down, right? Once you get better, you won't need to do all these, little factors. But if you're confused by this, breaking down to the little factors makes things very clear. Okay, so 4 is 2 times 2, x squared is x times x. Over here, 16 is 2 times 2 times 2 times 2 times x. Right, now I start with the 2's. Look at the first one here. It has 2 2's, but the other one has 4 2's. That means I need 2 more 2's. So I multiply by 2 times 2. I look at the x's. It has 2 x's. This one has only 1. So it's basically, I don't need any more x's. So I'm done there. I multiply the first one by 2 times 2. Now the second one, the 4 2's are there. Right? I have an x, but the other one has 2 x's. So I need to multiply by 1 more x. See, now both of them have 4 2's and 2 x's. I need them both to be the same, and now they are. Now I just multiply, right? Now I have 4 over 16x squared plus 3x over 16x squared, because that's 3 times x is 3x. That's how I got that one. Now at the top, I get 4 plus 3x over 16x squared. I can't combine these, right? These aren't like terms. So literally, you just get 4 plus 3x over 16x squared. Example number 2, I have 3x plus 12 over x squared plus 6x plus 8 plus 2 over x plus 2. Okay, now you would want to break them down and try to simplify them as much as you could. So I am going to factor the first one. The top and the bottom both could be factored, right? So factor them out, factor the 3 from the top. And the bottom is just a trinomial, factor them out. It's a regular quadratic factoring, right? So I get a bunch of factors here. The second one looks like it cannot be factored anymore. So I just leave that. Now, I'm going to try to simplify both of them as much as I could. The second one, I can't cancel anything. Remember, that 2 cannot cancel with that 2 because that 2 is stuck with this x at the bottom. But the first one, I can cancel out x plus 4 and x plus 4. Right? So you cross those out. You get 3 over x plus 2 over x plus 2. You see, it just so happens that now they're both having just x plus 2 at the bottom. So they do have the common denominator. So I can just add them. I get 5 over x plus 2. Because sometimes simplifying helps you get there. Sometimes not. Right? But you always want to simplify before you do any work to it. Example number 3, I have 4 over x minus 5 minus 3 over x squared minus x minus 20. Again, break them out, try to simplify them. So the only thing I can factor is this trinomial here, a quadratic expression. So I factor that, I get x minus 5 times x plus 4. Okay. Now there's nothing to cancel, nothing to simplify. So I'm going to try to make them LCD, right? Least common denominator. So I look at the first one here, it has x minus 5, but it's missing the x plus 4. So what I'm going to do, I'm going to multiply it by x plus 4 over x plus 4 for the first one. The second one has x minus 5 and x plus 4. It's not missing anything. I don't do anything to the second one. So I multiplied the first one, 4 times x plus 4 gives you 4 plus 16, for x plus 16, minus 3, you know, now they have LCD. I just subtract the top. 4x minus 16 minus 3 is 13, right? So 4x plus 13 over x minus 5 times x plus 4. Example number 4. Now, this one looks like you can factor both of them. So I break the trinomial down and I factor the right one. So it comes out to be like this. I have 5 over x minus 2 times x plus 3. That's the factor of the bottom. I factor the 3 out of the top. I have 3 times x plus 2. And the bottom, I get x plus 2x minus 2. Right? That's a common pattern. These are difference of squares. We learned how to factor them a while ago. X plus 2 over x plus 2 times x minus 2. Now, is there anything I can cancel out? Well, it looks like it. The second one can cancel out, right? I get x plus 2 cancel with x plus 2. That helps. The first one, there's nothing to cancel. So it stays like that. Now, I look at the first one. Does the second one have anything that the first one doesn't? The second one only has x minus 2. I do have x minus 2 here. I don't need to do anything to the first one. The second one looks like it needs an x plus 3. So I multiply by x plus 3 over x plus 3. And that gives you, the first one stays the same, but the second one becomes 3x plus 9. Okay, now I take 5, subtract that. Remember the negative sign here, it distributes to both of these. So I get minus 3x. 5 minus 9 is negative 4. So I have negative 3x minus 4 over that LCD. Last example here, example number 5. I have 5 over a trinomial minus 1 over another trinomial. Again, break them out into factors. So I factor them both. Is there anything to cancel top and bottom? Does not look like it, right? So I'm going to see what are they missing. The first one has an x minus 2, x plus 3. The second one has x minus 5, x minus 2. So they both have x minus 2. I don't have to worry about that. But the second one has an x minus 5. The first one does not. So I need to multiply the first one by x minus 5. The second one looks like it has an x minus 2, but it does not have an x plus 3. Right? So I need to multiply by x plus 3. Now they both have the same 3 factors at the bottom. You see? X minus 2, x minus 2, x plus 3, x plus 3, x minus 5, x minus 5. That's the whole goal. That's the LCD. They have to have all the same factors. So I multiply the 5 into these, okay, and the 1 into these. So I get 5x minus 25 minus, over here, 1 times that is just x plus 3. And I subtract. 5x minus x is 4x. Negative 25 minus 3 is negative 28. So I have 4x minus 28 over, that LCD